Welcome to the video lecture on boiler troubles. Before knowing boiler troubles, we would know some of the terms such as boiler, boiler feed water, and its requirements. So first let us see what is boiler. It is an apparatus setup or an arrangement which is used to produce steam in industries. The water used in the boilers, and when it is heated it would produce steam. That water we call as boiler feed water. Water used in boilers to produce steam is known as boiler feed water. This boiler feed water should meet up certain requirements. If it doesn't satisfy the requirements, it would result in the disadvantages caused to the boilers, which we call it as boiler troubles. Now let us look into the requirements and the causing by boiler troubles. Requirements of boiler feed water. The boiler feed water should be free from hardness causing salts such as calcium bicarbonate, magnesium bicarbonate, calcium sulfate, magnesium sulfate, etc. Number 2 is it should be free from dissolved salts and alkalinity. The second requirement is it should be free from dissolved salts and alkalinity. Third requirement is it should be free from oils and greases. Fourth requirement is it should be free from dissolved gases. Dissolved gases such as carbon dioxide, oxygen, etc. If these requirements are not satisfied, it would result in the boiler troubles such as scales and sludges. If the water consists of dissolved salts and alkalinity, it would result in caustic embrittlement. If the water consists of oils and greases, it would result in priming and foaming. If the water consists of dissolved gases, it would result in boiler corrosion. So these four are known as boiler troubles. Scale sludge, caustic embrittlement, priming foaming, and boiler corrosion are together described as boiler troubles. So boiler troubles it is a disadvantageous caused to the boilers when we use an untreated water directly from the water source. If the water doesn't contain any of these criteria, such as hardness causing salts, dissolved salts, oils and greases, dissolved gases, then the boiler would be free from all these boiler troubles. So, untreated water used directly into the boilers So we all know the boilers are used in industries which would require large amount of water. So that water we cannot get it from the other sources. So we directly take it from the lakes or the nearby water sources. So it may have some of these salts and it would cause the boiler troubles. So this is the introduction about boiler troubles, where we have seen about what is boiler and what is the purpose of the boiler. It produces steam in industries, and boiler feed water, which is the water used in boilers for producing steam. And this boiler water, what it should be and how it should be free from hardness causing salts, dissolved salts, alkaline salts, oils, greases, dissolved gases. And if it is present, it would cause some of the disadvantages. So let us look one by one. The first boiler trouble we are going to discuss is caustic embrittlement. The term caustic embrittlement gives us the idea as what it is. Embrittlement is a small breaking or cracks which would occur in the boilers. So we describe it as intercrystalline cracking of boiler metal. What is that intercrystalline? Is a minute cracks which occur inside the boilers, within the boilers. So we will not be able to see the crack. It will not be so obvious. Okay, so we have seen what is embrittlement. Now, what is the reason for this caustic embrittlement is? The reason is excess sodium hydroxide. So the reason for the intercrystalline cracking of the boiler metal is sodium hydroxide. Now let us see how is the sodium hydroxide present in the boilers. The sodium hydroxide comes when we use sodium carbonate as the softening agent. Sodium carbonate, when it is used as a softening agent in the conversion of the hard water to soft water, it would result in the sodium hydroxide when it is being heated. So sodium carbonate, when it is heated with water, it would result in the formation of sodium hydroxide and carbon dioxide gas. Now we are able to understand the sodium hydroxide from where it comes. It comes as a result of heating sodium carbonate. This sodium carbonate will be present in the water source itself when we use it as the softening agent. So when we add this chemical in the softening process, it would be converted to sodium hydroxide on continuous heating. This would get precipitated. Now, how does the sodium hydroxide cause this intercrystalline cracking is, the sodium hydroxide would occupy the hairline cracks. It's a minute cracks of boiler metal. So what it does to the boiler metal is, this sodium hydroxide would convert the insoluble iron metal. Iron is metal used to make the boilers. So it would convert the insoluble iron metal to a soluble sodium ferroate substance. And hydrogen gas. Soluble sodium ferroate. So this sodium ferroate will go and accumulate in the cracks, and it will deepen the cracks in the boilers. So what does the sodium ferroate does is, it will deepen the cracks which are present in the bends, joints, etc. By this manner, it would result in the eating up of the boiler metals, resulting in caustic embrittlement. So it's a indirectly how the sodium carbonate is converted into the sodium ferroate, and how this sodium ferroate is resulting in the caustic embrittlement we are able to understand. Now we have seen what is caustic embrittlement, what is the reason for the caustic embrittlement, and how it works, the mechanism we have seen. Now we shall see the preventive measures, that is very important. It's a very simple method where it can be avoided by adding sodium phosphate instead of sodium carbonate. So instead of sodium carbonate, sodium phosphate has to be added. So by this we can avoid this caustic embrittlement. So if there is no sodium carbonate, then there will not be any formation of sodium hydroxide. If there is no sodium hydroxide, then there will not be any formation of sodium ferroate, so which we can avoid this caustic embrittlement. The second way is by using waxy materials. So this materials we would use as lining. Some of the waxy materials are we are going to coat it as a paint in the inner walls of the boilers. So some of the waxy materials are tannin, and lignin. So we would be coating these waxy materials in the inner walls of the boilers. So what does this do? We are using sodium carbonate as the softening agent. So when we use a sodium carbonate, it would result in the formation of sodium hydroxide. So sodium hydroxide formation is there, but we can avoid the sodium hydroxide in direct contact with the metal by coating it with this tannin or lignin. Third is by adjusting the pH. So we avoid the alkaline pH and we would maintain the neutral pH, by which we can avoid this caustic embrittlement. So this is the first boiler trouble we have seen. What we have seen, what is caustic embrittlement, what is the reason for caustic embrittlement, and what was the mechanism of caustic embrittlement, and what are the preventive measures. So some of the methods have been listed here by which we can avoid this boiler trouble, which is caustic embrittlement. We shall now move on to the second boiler trouble, which is priming and foaming. Now let us see what is this priming, foaming, what is the reason for it, priming and foaming, and what are the disadvantages and how it can be controlled or prevented. First, let us look into priming. Priming is a process of production of wet steam. So priming is nothing but production of wet steam. We have heard the term steam. What is its wet steam is? We know steam is in the gaseous state or in the vapor state. When water molecules are mixed up with the steam, then it would result in this wet steam. So priming is the production of wet steam where some molecules of water droplets are carried along with steam. So we give a term for this as carry-over process. As water is carried along with steam, we give this term as carry-over process. Now, what is the reason for this priming is? Some of the reasons are listed here as poor boiler design. If it is broad at the bottom and narrow at the top, then it may result in the production of wet steam. Number 2 is improper boiling rate. When we don't maintain the temperature or the time, it would result in this priming. Improper boiling rate. Number 3 is when there is a high velocity of steam production and the high water level. These are the reasons by which it would result in the wet steam. So high steam velocity is a third factor which is resulting in priming, and the last factor is high water level. Okay. So we have seen what is priming and what are the reasons for priming. Now we shall look into the methods by which this can be avoided. It's a very simple thing. Whatever we have listed here as a reason or causes, when we just overcome this, we would be able to eradicate, or we would be able to remove this priming process. So the preventive measures are as the boiler design was poor, we have resulted in this priming. So the boiler design has to be made good. So good boiler design will help us to avoid priming process. We need to maintain the boiling rate temperature by which again we can reduce or we can stop this priming process. Proper boiling rate. The temperature, time, everything has to be maintained. The third preventive measure is regulating the steam velocity. The last preventive measure is maintaining the water level always. So in some case, they would require high steam production, so they may increase the water quality, water content in the boilers, by which it may result in this wet steam in case the boiler design is poor. So we have seen what is priming, what are the reason for priming, and how it was overcome. Now let us look into the next boiler trouble, which is foaming. The word foam tells us it is related with some bubbles. So what is this foaming is? Very simple in a way. It is the production of or formation of stable bubbles over the surface of boiler feed water. It is the formation of stable bubbles on the surface of the boiler feed water. So we shall see what is the reason for this foaming. It is the presence of oils and greases. So from where does this oils and greases come is, when during rainy seasons the water would have been washed up from the road and from various other industrial outlets, they would contain some of the pollutants which carry the oil leakages or grease. So that would be the reason for the foaming boiler trouble in the boilers. Now how can we overcome this foaming? Here we are going to use chemicals, as well as we are going to use an equipment setup by which we can remove this oils and greases. So the first one is we are going to use a chemical known as the anti-foaming agents. by using anti-foaming agents. Like synthetic polyamide, castor oil, cottonseed oil, so these are some of the anti-foaming agents which will not allow the oils and greases to form the stable bubbles in the boiler feed water. The second one is by adding coagulants. If the oils and greases are scattered in the boiler feed water, it would just club them and it would make them to settle down. So by adding chemicals called coagulants, such as sodium aluminate, aluminium hydroxide. So foaming is the formation of stable bubbles over the surface of the boiler feed water. This is caused because of the presence of oils and greases. It can be avoided by a simple chemical method by adding anti-foaming agents such as synthetic polyamide, castor oil, cottonseed oil, and by adding coagulants such as sodium aluminate, aluminium hydroxide. Now let us look into the physical method. Physical method is we would use cataphoresis. Here highly charged electrodes are used to separate the oils and greases from the boiler feed water. So cataphoresis is a physical method where we will be able to use the highly charged electrodes to separate oils and greases. So we have seen the second boiler trouble, which is priming and foaming. Let us move on to the third boiler trouble, which is scales and sludges. When water is continuously heated to produce steam in the boilers, the amount of the dissolved salts or the hardness causing salts would reach the saturation level. So when it is reaching the saturation level, it would get precipitated as a loose precipitate forming sludges or a hard precipitate or a coating forming the scales. On overheating water continuously, hardness salts would reach up this saturation point. Saturation point is the highest level. When it is reaching the saturation level, it would result in precipitate formation, and it would ultimately result in this sludges and scales. So if the precipitates are soluble, we call it as sludge. If it is insoluble, we call it as scales. Now let us look into the differences of the scales and sludges one after the other. First, let us see what is sludge. Sludge is the soft precipitate. How will we describe the sludges? We have seen how is the sludge arising or the scales are arising. When we overheat the water and continuous heating, it will result in the precipitate. This precipitate only we call as a sludge. So sludges will look like a soft, loose, slimy, and non-adherent precipitate. So sludges are described as soft, loose, slimy, non-adherent precipitate which would be soluble with the boiler feed water. Okay. So first we have seen what is the definition or the description of sludge. Next we would see the reason for this sludge. It is caused due to the presence of hardness salts. Some of the hardness salts which result in sludges are magnesium sulfate, magnesium chloride. So this we call it as the hardness causing salt. So sludges are resulted as a result of the presence of hardness salts such as magnesium sulfate, magnesium chloride. Now let us look into the disadvantages or the demerits of this sludge. Coming to the disadvantages, it would result in the wastage of fuel. Where are we using the fuel is? Fuel is used to heat up the boilers to produce steam. So when the sludges are mixed up with the water, it will act as a poor conductor of heat. So then it will not allow the 100% of heat to get transferred to the boiler metals, by which the water can be converted to steam. So it results in, it becomes as a poor conductor of heat. Third is, this sludges will choke up in the valves or vents or in the pipelines, and by which it would decrease the efficiency of the boiler in producing steam. Cause choking of boiler metals. Number 4 disadvantages, it would decrease the boiler efficiency. So the boiler will not be able to efficiently produce steam, and we will not be able to convert the water completely into steam. So that would result in the decrease of boiler efficiency. These are some of the demerits or disadvantages of sludge formation in boiler feed water. Now we have seen what is sludge, what is the reason for sludge, and what are the disadvantages of the sludge formation, and now we would see the removal or the preventive measures. So one method is we have to use soft water or the pre-treated water by which we can reduce or we can avoid the sludge. That process we call as blow down operation. In a simple way we want to explain is the hard water is replaced with the soft water or the fresh water. How does this happen is without stopping the steam production. On one end we would be removing the boiler feed water which is being filled up with the sludge formation or the precipitate, and the other end we would be adding the soft water or the fresh water. So continuous replacement of hard water with fresh water without stopping the production of steam. So it's very important in industries. If we stop the steam production and carry on this blow down operation, it is a time consuming and it is not an energy efficient process. Here it is more good enough in the way that we will be able to replace the hard water or the sludge filled water with the fresh water without stopping the steam production. So we have seen the boiler trouble, sludge, what is sludge, the reason, and how the sludges will cause the disadvantages to the boilers and how it can be prevented. Now we shall move on to scales. It's just the opposite, and before moving on to scales, we shall see the representation of sludge. Is the representation of the boiler metal, boiler feed water, and this sludges, as it is soluble, it will be present along with the boiler feed water. So this is the representation of boilers, and inside the boilers, boiler feed water are taken, and the sludge formation happens because of the presence of the hardness salts such as magnesium sulfate and magnesium chloride. Now we'll move on to the next topic, which is scales. So here scales would be just opposite to sludge. It is not soft, it is hard, thick, strong and adherent coating. Here it is not a precipitate. The precipitate, due to continuous boiling, it would become a hard coat lining. It will not be soluble with the boiler water. It would be occupying the inner walls of the boiler metal as a thick lining. In our houses, all in some, whenever our water is a hard water, we could have seen this kind of scales deposition in pressure cookers, in vessels, in tap or in the bathroom floors. We would have seen this kind of scales. It would be a hard lining because of the presence of hardness salts. Here the reason is calcium sulfate, calcium bicarbonate are some of the hardness salts which would result in the scales in the boilers. We shall move on to the demerits and disadvantages of scales. It also results in the wastage of fuel. It acts as an insulator of heat. So it doesn't transfer any of the heat which we provide in the steam production. So most of the fuel will be wasted. So it would result in the decrease of boiler efficiency. The boiler will not be able to produce the steam as effectively as expected. It causes explosion of boiler metals. How big disadvantages it is, explosion of boiler metals. We would have heard this in many of the newspapers, the boiler metal have got exploded. How is this happening is, if the thick lining of the boiler metals, we shall see the representation. So if any cracks or a small pit or hole happens in the boiler, in the scale formation, then because of the pressure variation and temperature rise, it may lead to the explosion of the boiler metal. So any cracks happening in the scale formation, it would result in the explosion of boiler metals. So due to cracks in the scale lining, it would cause the explosion of the boiler metals. So this scale would result in the wastage of fuel, because in industries, cost-wise, it has to be efficient enough. Here we will not be able to satisfy as the fuel is being wasted, and it acts as a poor insulator of heat. So the 100% heat will not be used up in the steam production. It may lead to explosion if not taken care, and decrease of the boiler efficiency. So there are many preventive measures. Let us see one by one. So some of the preventive measures are by external treatment. By external treatment of boiler feed water. So some of the external treatment methods listed are ion exchange process, zeolite process, what is this external treatment is, before adding the boiler into the boiler, we need to remove some of the hardness causing salts or various ions which would result in these scales and sludges. So this is an equipment setup which we name it as ion exchange process and zeolite process. So this is a representation of the scale. I shall write here. The second is by internal treatment. As I told you, external treatment is an equipment arrangement by which we can remove the hardness causing salts. Internal treatment is purely by adding chemicals such as sodium carbonate, sodium phosphate, sodium aluminate, agar, so all these are used as the softening agents. By adding chemicals like sodium carbonate, gelatin, sodium aluminate, etc. Sodium phosphate, all these can be used as the chemicals in the internal treatment of boiler feed water, by which we will be able to remove the scales. Third preventive measures is by acid treatment. In our houses or places we want to clean up the bathroom tiles, we would be using some of the hardcore acids. So the same way, if we want to remove the scale formation in the boilers, we have to stop the steam production, add dilute acids such as HCl or sulfuric acid or even nitric acid would be added to remove the strong adhered scales. The fourth preventive measures is by using or by giving up the thermal shocks or thermal agitations. A sudden vibration along with the increased temperature would make up the scales to fall down, by which we will be able to prevent the scale formation. The last one is by using some wire brush or scrapers. So by which we can scrape it and remove the scales and sludges. So these are the boiler troubles we are seeing for this class. Thank you all. Thank you, students. We would see this remaining things in the next class. Thank you all.